Hi, everyone, and welcome to the final session of today. I'm happy to introduce Alex Soto to you. Alex will be our speaker for next 40 minutes. And yeah, a couple of words about Alex. Alex is a director of developer experience at Red Hat, and he's passionate about Java world. Of course, it's Java conference, as everyone here, and also about software automation. And he also believes in the open source software model. Alex, I think that we can start. Just don't want to prevent our listeners longer from diving into your awesome talk. So yeah, let's begin.
Thank you very much, Alina. I'm going to share my screen. Okay, I'm going to hide this and here. Okay, so let's start. And first of all, thank you very much for joining my session. Well, since it's, at the end now it's a virtual world, so I don't know if I will say good morning, good evening, good afternoon, or what. So good, whatever you want. And thank you very much for joining, as I said, to this serverless-native Java with Quarkus. Just everything that I'm going to show you today, the demos and so on, you can replay it on your own at home. Here in the end.dev/knative tutorial, you can get all the Git. It's at the end, it's a GitHub repo where you can find all the instructions and reproduce almost everything that I'm going to show you today. And also you've got, the end.dev/knative master. Okay, this is the link for the slide. So you've got everything that I'm going to show you today. It's free and you can use it on your own at home. So yeah, my name is Alex Soto. My Twitter is AlexSotoB, and my email is sotowe@redhat.com. If you've got any question, maybe later after the session, maybe if the session is recorded, maybe when you are replaying the session, feel free to ask me on Twitter or in email. That's perfectly fine. And yeah, I'm the co-author of Testing Java Microservices in the Quarkus Cookbook. So yeah, also there is this Knative Cookbook, which is a free Knative book. You can download it. You just need to go to developers.redhat.com, and then you just simply register, and then you can push the download button, and you download this book in PDF format. So what is serverless? There's a lot of different definitions of what is serverless. So some people confuse serverless with FaaS, with function as a service, and it's not exactly the same thing. I don't want to go deeply to this, but in my opinion, and in the opinion that we've got in Red Hat, serverless is not having not servers, of course, but it's just about deploying your applications, your services, without requiring any server management. All this server management thingy, it's happening automatically. It's managed by the cloud. So you, as a developer or as a DevOps engineer or DevOps people, you do not need to manage servers at all. And one of the great things about serverless is that they are scaled up and down automatically. So it means that you are paying for what you use, right? And one of the specific things of serverless is that you can scale to 0. It means that if there is no request, then there is no service deployed, which means that you are not consuming CPU, you're not consuming memory, so your bill is lower. A bit of a short history of serverless. It's considered the first time that we've got serverless was in March 2006 with AWS S3, but of course, I think that what really popularized serverless was AWS Lambda. Then after 2 years, it came Google Cloud Function, Azure Functions, and so on. Okay, so but at the very end, this is about functions. As I said, there is this somehow mix between functions and serverless. But for me, serverless is just the generic term, and functions is just a specific use case of serverless. So some people ask myself to me, do you prefer a microservice architecture, or I need to use a serverless or functions architecture? Well, at the end, it depends, right? You can mix both approaches, of course, that's perfectly fine. In fact, a lot of our clients are, using both approaches in the same architecture or application. But if you are asking yourself, better microservices, better serverless of functions, I would say that it depends. If you want to control everything, how you deploy the functions, or sorry, how you deploy your services, your applications, if your services are going to be a long life processes, and when we say long life processes, I mean processes that are not going to be restarted in maybe 1 month, 2 months, 3 months, something like that, long life process, okay? You want to know exactly the programming model that you want to follow. And usually you are using synchronous communications, right? The most typical one is the REST APIs. So you send the request and then you get a response. Then go to microservices, okay? But if you want to go to something that you don't want to manage all the life cycle of your application, nor the server management, you want that the cloud controls all these kind of things, then go to serverless and functions. Moreover, you also need that these services, these functions need to be short life processes. And they need to be short life processes either because they do not have a lot of requests. So maybe it's like, I don't know, at 1 p.m. there is always a process that's running, and then it goes down, and until 2 hours there is no more workloads on that service. Or maybe because you're updating constantly. Maybe you're updating every day or every 2 days. There are some kind of services that requires these kind of things. Okay, so if you are thinking on updating services every this 2, 3 days, 4 days, then go with serverless as well. And one thing that you need to know is that usually serverless and function uses an event-driven asynchronous communication. So it's like sending messages and receiving messages, although it's not forced. So you can use serverless and functions with synchronous request response. In fact, if you start mixing microservices and serverless architectures both in the same application, usually you end up by using synchronous communications. But of course, you can use request response in serverless, request response in microservices, or you can use an event-driven asynchronous API in microservices and also in serverless. This is just what we typically see in the world, but it's just your choice. Use the communication model. So let me introduce you a bit of Kubernetes. If we think about us in the past, we will have something like a monolith, right? We've got our application with our databases, and we deploy this application maybe once per month. Well, maybe I say once per month, no, once every 3 months or every 6 months. So we updated our application with this thing, right? 6 months or 3 months or something like that. But nowadays, maybe like 3-4 years ago, more or less, we decided that it would be a good idea to break down this monolith and start this microservices architecture, or I like to call it service architecture, right? Because at the end, what we are doing is services that all of them are communicating with the network. And what we get with this new model is that we can deploy several times per week. Okay, so sometimes it's like we update this service once per week, this service once per week, this service once per week, service this once per week, right? So you can see that in average, maybe we're updating one of these services or all the application, in a better way to say that, like all the application receives an update at least one every day. And we need to find an easy way to deploy these services. And nowadays, the de facto tool for deploying microservices is Kubernetes, right? Of course, maybe if you are using OpenShift at the end, it's Kubernetes. It's an implementation of Kubernetes. So maybe you're using Kubernetes, maybe you're using OpenShift. It doesn't matter because it's a Kubernetes. So how we can get these serverless workloads in Kubernetes? Well, using a project that is called KNative, right? KNative is just a project that was announced on 2018 and basically allows you to deploy and manage serverless workloads on Kubernetes. And one of the great things about Knative is that it's built atop of Kubernetes concepts. So everything that is valid in Kubernetes, it's valid in Knative. And if you know Kubernetes, it's really easy to move to Knative. The second one is that as it's a Kubernetes thing, it's container-based. So instead of having some kind of, proprietary API to run the service, it's just a container, the well-known Docker containers, if you will. And another thing is that they can run anywhere, and that's really important. If you are using, for example, AWS Lambda or Azure Functions or GCP Functions, you are creating a vendor locking on your code. But if you are to start using Knative, and since you are using Knative, you are going to move to Kubernetes, then you can use the serverless components in a generic way, on-premise installations, in the cloud, or even third-party data centers, right? Because at the end, it's Kubernetes, and Kubernetes runs everywhere. Some of the interesting capabilities of Knative, well, that since you can scale to 0, it means that there is no pod. When you are scaled to 0, no pod. If there's no pod, it means that you're not consuming memory. So if you are in a public cloud, it means that your bill is going to be lower because they cannot charge you for something that you are not consuming. The scale from 0 also means that when you start receiving some traffic, some pods are getting started. And you can define when to increase the pods. So you can, for example, say, okay, now there is 0 pods. When I receive one request, I want 1 pod. And if I see that there is a traffic spike with a bunch of requests per second, then start booting up more and more pods. Another thing is that, for example, you can also get configuration and revisions. So when you create a new service, automatically there is a new revision of the service. So you can always do blue-green deployments or canary releases. So you can always, if you find any bug in the new version, you can always switch back to the older version. At the end, since it's Docker, or sorry, not Docker, it's a container, then you can use Tecton for building these container images. And one of the interesting things is that Knative works in request response model and also with the eventing system. So you can choose with Knative if you want to use the traditional synchronous request response, or use, for example, an eventing system, for example, using Kafka. So let me show a demo before we get starting to white Quarkus, okay? And this is my cluster. I've got here my cluster. You can do kubectl get pods, and you will see that there is no pods, okay? And for example, I can do kubectl get nodes, and you'll see that there are 3 worker nodes and 3 master nodes. In this case, I'm using my Kubernetes cluster. In fact, it's an OpenShift cluster, okay? And it's running, I guess, in Frankfurt, if I remember correctly. So, okay, now, I'm just going here for nothing, but now I'm going to show you which services I've deployed here. And to do that, I'm going to use KN. KN is Knative CLI tool, and I'm going to do KN service list, and you can see that I've got 2 services. If you want, maybe it simplifies you if I tell you that it's like 2 functions. One function that returns a hello world, which is running in Quarkus, and another function that just returns hello world that is written in Spring Boot. Okay, now let me do a watch here. Okay, notice that now there is nothing, and here I'm going to run this script. But basically, this script, the one in your right, it's starting to curl to the version of Quarkus, and this left one is doing the same, but in the Spring Boot application. So I'm going to run it. Oops, now. Okay, notice how the containers are getting started. There was no container, now they are starting. And after a few seconds, you can see that now here, oops, it's happening now. There is some error. Okay, now notice that now there was a delay between Quarkus and Spring Boot. The Quarkus application started getting the response pretty fast, but Spring Boot took more time. There was some kind of issues in my cluster. I don't know what, but yeah, we'll see that. Okay, so you can see that Quarkus is start serving a response faster than the Spring Boot version. Okay, in fact, if you want to see this, I can do a kifcarl logs of the Quarkus container. I can do -c user container, and something happened here wrong. Yeah, not this. It's starting in this. What's happening? I think that I deployed the wrong version. Okay, I've deployed the wrong version of Quarkus. It's interesting. I don't know why it's happening this, but I can fix it really quickly. That's fine. I'm going to do KNative list. I'm going to kn delete this. KNative delete. Okay, and I'm going to, it's really easy, just deploy a new service. KNative, I've got here, no worries. You can see now how can I deploy a service. I can just do KNative create, let's call it greeter, which is the greeter one, and here the namespace is KNative serverless. Okay. What? KNative serverless. Yeah, oops. What is this? Yeah, this is the namespace. Well, okay, demo gods are not with me today. Okay, serverless KNative. Okay. We're almost there. Sorry for that. Native. Okay, now. So now I'm just going to deploy a new KNative service. Notice that I'm not dealing with anything related to the YAML files, nor service management, nothing. I just do KN service create greeter in this namespace with this image. I'm done. Okay, and now we need to wait a bit because by default, when you create a new service, the pod becomes available, and that's fine. Let me do a clear here and a clear here. And if now I do this one, you can see that now the pod is running. This greeter deployment, the one that is Quarkus, is running. But when we arrive to 1 minute, the pod will go to scale down to 0. The reason is that there are no requests. Since there are no requests, you can just kill this pod. Then let's wait this minute. Now notice that the pod is terminating, no request, that it terminates, and you are freeing these resources. Okay, now let's repeat the experiment. Now hope that it's going to work better. Here and here now, because I deployed the wrong Quarkus application. Sorry for that before. Now let's start it. And I'm just waiting for this to terminate, so we don't have this mix. Well, I don't think that we can do it now. I'm going to run the Quarkus. Wait, this is not the service list. This is the URL. I'm going to copy this URL here. We're almost done. Okay, now I'm going to run a URL here. Start sending requests to the Quarkus application and start sending requests to the Spring Boot application again. I run it and run it. Okay, now notice that the process is starting, and notice that now Quarkus is starting sending requests. Okay, so it's booted really fast, and Spring Boot still not serving any requests. And finally, yes, Spring Boot became available and start serving requests. So you can see that when we use a Quarkus application, it starts really fast. And as you might expect here, when we are in a serverless architecture where we scale to zero, it's really important to have a really fast boot up times. Okay, even if you want to know exactly the boot up time, I can just do this kubectl. I can do it here. Kubectl logs this of -c user container, and you can see that it started with 5 milliseconds. So really, I will show you the code in a few moments, but this is a Java application written in Quarkus that starts in 5 milliseconds. So as you can see, this is the best choice when you want to move to serverless workloads. If you want to see also the Spring Boot ones, let's see if it's still there, the pod. Yeah, kubectl logs -c user container. In this case, it started in 6 seconds. Yeah, you see that there is a major difference between using a Quarkus and a Spring Boot. And it's not only this, it's also about memory. Let me go here. This is the OpenShift interface. You see that at the end, I'm just using kubectl and kn because it's at the end, it's a Kubernetes, but I can go here to the dashboard. This dashboard takes things from Prometheus. Let me move to Knative serving. And this is the greeter, this is the Quarkus one, and see that the Quarkus one, it's using at the beginning, it's the red one, it's using like 35 megabytes of RAM. Keep in mind this, Java application that only uses 35 megabytes of RAM. But if I choose now the greeter Spring Boot, you'll see that, okay, it takes 200 megabytes of RAM, and there is a spin up to 300, right? So a bunch of more memory and slow boot up times between Spring Boot and Quarkus. And let's do some kind of more slides, and then I will show you all this demo more slowly. Knative comes with two components: Knative serving and Knative eventing. Knative serving is when we want to use this request response approach. Knative eventing, as you probably are thinking out about it, is that it's about events. So usually when we are using Kubernetes, we've got these elements: deployment that creates the replica set creates pods, and then we've got the service, which acts as like a load balancer for providing a static DNS and IP for a group of pods, right? Then, when we are using Knative, we've got exactly the same name, which is a service, but notice that the kind is different. It's serving.knative.dev. Okay, this is the Knative service. When I do kn service list, it's this service and not a Kubernetes service. Then we've got a configuration where we configure our service. We've got a route to access this service. You've seen that I just did kn service list, and there is the URLs. I just start, picking these URLs without, taking into consideration anything about configuring ingress or nothing like that, because remember that we are in serverless world, so I don't want to take care of these things. And in case of Knative, every time that we deploy a new version of the service, we create a new revision. Okay, so if we deploy one service, after 3 days we deploy another service, then we've got 2 revisions of the same service, and we can always switch back to the previous version. And if you read some things in internet about Java, I mean, here it's about Spring Boot. At the very end, it's about Java. Okay, they say that Spring Boot is designed for long-running services and not to be used as lambdas or as serverless and so on. Then again, it says the bigger problem using the Spring and Java in general. I mean, it's important. I'm just focusing on the Spring, but at the very end, it's about Java, I think. Okay, it's that lambda execution cost rise with memory usage. So the more memory usage you've got, the more you're going to pay. So most of the Java frameworks out there assumes that the memory is abundant and it's cheap, which is in case of the serverless. And another thing that, well, that is that in Java, the startup time is usually a huge boot up time, right? Because you need to start the JVM and then start the process. Okay, so what is Quarkus? Well, Quarkus is a new Java framework. Well, not that new because now we are version 1.9, so, but maybe it's like 1 year and a half, more or less. Yeah, more or less like that. 1 year and a half or 1 year. Okay, and we say that with Quarkus you get supersonic, supertonic Java. Why? It's supersonic because it boot up really, really fast. You've seen that, 5 milliseconds. It's superatomic because it uses not much memory. Instead of 200 megabytes of memory, we are just using 30 or 35 memory. And it's Java. You use Java. In fact, you use enterprise Java API, JAX-RS, CDI, JPA, Beam validation, all these well-known Java libraries are used by Quarkus. But what's happening is that we are using GroupVM to take all Java program and compile it to a native executable. A native executable, as it's in Go, it's in Node.js and so on. Okay, so you are having a binary file that is executed in machine codes. Okay, and for this reason, since you are not starting the JVM, since you do not need a JVM, we can boot up really fast and with low footprint memory. Basically, what we are doing is just creating our runner jar, the typical runner jar, which means that you can still use Quarkus inside a JVM because it's a normal jar file. Okay, so if you feel comfortable with JVM, if you are going to run a long life process or a microservices architecture, you can still use Quarkus because it's a jar file that you can run it with java-jar. But if you're going to use Quarkus in serverless mode, you want fast boot up times, low memory footprint, and so on, then you can do this native compilation process, which gets all this jar file and transform it to a native executable. And one of the side effects of using this compiling to native is that you are increasing the density deployment. Okay, so now instead of deploying 5 services in a node, you can deploy a lot of more services in the same machine. The reason for that is that if you require less CPU, if you require less memory, it means that you've got more memory on that server to be used, which means that you can deploy more services in the same server. And of course, the effect is that you are increasing the deployment density because you can deploy more services in the same server. So how you can get, or how you can construct a Docker image that uses Quarkus and can boot up in 5 milliseconds? Well, you can just do this thing. Maven wrapper package. This is Maven, okay? -p native, -d Quarkus native container build equal true. Okay, this thing creates the native image. So it takes the jar file and creates a native binary for this jar file. And then if you want, you can just create Quarkus container image push equal true, which basically what it does is use zip to create a Docker image and push it to your registry. So with just this attributes or these properties, you are compiling to native, so you get the pretty fast executable of your Java application, and you create a Docker container and you push it to your registry. And of course, if you want to do even more things, what you can do is deploy Kubernetes.deploy true and Kubernetes deployment target knative, and then after the creation of the container and push it to the registry, it's going to deploy it as a Knative workload. So let's go to more demos because this at the end is what we like. Let me see, time left. Oh, 10 minutes left. Okay. Then let me go to the demo. Stress time. Okay. Now Let me show you a Quarkus application so you can see how it looks like. Go to the greeter, Java Quarkus. This is the Quarkus application that you've seen before. And what I want you to see is that it's just a JAX-RS CLI application. This is a Quarkus application that uses JAX-RS and CLI. There is nothing that is proprietary to Quarkus. It's just, JAX-RS endpoint with inject to inject the resources, and this path get produces text plain. So if you're familiar with JAX-RS, you know what is this. And then also we are using here the config property for injecting configuration properties, and we are using another specification, which is the Eclipse microprofile config spec. Okay, so there is nothing proprietary to Quarkus. Everything is just in the specification. So everything that it works in the enterprise Java APIs can be used in Quarkus and can be compiled through native. Then if you want to generate a project, you just need to go to code.quarkus.io. Okay, it is here. Okay, code.quarkus.io. And then you can just need to select the group, the artifact ID. You select, I don't know, you want to use JAX-RS, maybe you want to use, I don't know, Hibernate. You want to use Hibernate ORM, maybe you want to use MariaDB, because you choose MariaDB driver and so on. Then you push generate, and it generates this application. And basically, you will get something pretty similar to this code base, okay? But I don't want you to spend time on compiling and creating the Docker images, because one of the things that you get when you are when you're compiling to native is that this process takes like 1 minute and 1 minute and a half. And I don't want to spend 1 minute or 1 minute and a half having you here just watching log lines. Okay, so I already have all my Docker images created. One of the things that I want you to remember is that to deploy a new service, you do kn create, kn service create. Okay, you put the name, the namespace, and the image, and it just works. It's deployed. That's very cool. Okay, but you can do it in other way around. So let me do a kn service list again, and let me eliminate this kn service, delete this kn service delete this other one. Okay, and now let's deploy two greeter services, version v1 and version v2. But in this case, what I'm going to do is do it with a YAML file. Okay, notice that this is the greeter service v1, which is, instead of using kn service create, it's just a YAML. Notice that the API version is serving KNativeDev, the kind of service, and here you set the image. And in this specific case, I want to set the liveness proof and the readiness proof. So I can just go here and do Kafka apply -f service reader service v1, and notice that now I'm just applying as I usually do with Kafka, but in this case, this resource is a Knative resource instead of a Kubernetes resource, and I can do Kafka apply -f return v2. Now I can do kn service list, and you see that there is only one service. And probably you're saying, why there is only one service if you deploy two services? But remember that I said before that with Knative, we've got the concept of revisions. So I can do kn revision list, and you see here that there are two revisions, one revision v1 and another revision v2. And in this case, all the traffic goes to greeter v2. So now I can just go here again and do a call. Okay, copy paste error. Here we go. Call, and I get it namasted. I get it namasted because if you check here, I'm just setting the greeter v2, and I'm setting an environment variable with message prefix, which says what is the prefix for your message. In this case, it's namasted. If you check here, there is nothing, so it means that it's high. So I can just do quotes, and I'm getting always namaste. Now, what's happening if I want to change that traffic? Okay, I just need to apply another YAML file. Here it is, where basically I'm saying the traffic, I want to send all the percentage. Here it's exactly the same thing, but in this case, I'm saying that the traffic is 100% to Greater V1, 0% to Greater V2. So I can go here and do kubectl, apply, -f, service pin. Okay. I do k. It's an alias of kubectl. Okay, so you can do kubectl. I can do kubectl and I can do k, and it's exactly the same thing. Okay, now I can do kn revision list, and now you can see that all the traffic goes to v1, and I can do a curl. It's exactly the same curl, and now I'm getting high instead of namaste. So it's really easy to do this kind of blue-green deployment, or even if you will, you could use a canary release by setting here 80-20 or whatever. Okay, so nothing prevents you to use a canary release of blue-green deployment. And you see that it's really easy to do. I can do now a KN service delete greeter. And let me show you the last thing, and hope that I've got still some time to show you. Okay, 3 minutes. Yeah, I think we've got time. Let me show you how you can scale up automatically. So I'm going to deploy this service. kubectl apply -f service 10. This service 10, it's nothing. It's not. Well, it's not. I mean, it's just service 10. It's just a new service, but now I'm saying that every pod can only get 10 requests in parallel. If you get it 11 requests, then you need to scale up and create another pod. Okay, so I'm going here and I do a watch. Notice that now there is one prime generator. And what I'm going to start doing is burst. So I'm going to use Hey. Hey is a CLI tool that allows you to send 50 concurrent requests during 10 seconds. Okay, so I run it. And basically what you're going to see here is that I'm scaling up a lot of pods because, well, you know, you're getting a bunch of traffic, and I put it 10 as a limit. Of course, maybe in a real case, you will put 100, but you see how things are scaled up automatically. And if we wait for 1 minute, you see how this burst goes down in a few seconds. Meanwhile, I finish my slide because I'm still 2 minutes. Then we will see how all these pods has been terminated automatically. So the other thing is Knative eventing, which allows you to react to events. Okay, to events. So basically, how this works is that I've got now my Knative structure, but instead of scale up and down because of requests, you scale up and down because of messages, of events, right? Of events. So, for example, I've got a Knative event source, which could be a Kafka message, or it could be a GitHub trigger it, or it could be an Apache Camel endpoint. You get it to the sink, to the broker, and then you can define filtering messages. For example, I can say if the filter, if the message contains the word green, then send a trigger or trigger this message to this KNativeService green, and if it's red, to the KNativeService red. And if there is no messages, the KNativeService green is going to scale down. And when I get it, the first message with the word green, then I'm going to scale up one instance. And of course, if I get it more and more messages, then you will get more and more pods. Okay, and some of the Knative's event sources are GitHub, WebSockets, AWS SQS, GCP Bootup, and Apache Kafka. Notice that Apache Kafka is just your tool, right? Because if you're using event-driven architectures, probably you're using Kafka. And what you're getting here is that when you send a message to a topic, then you are getting a link between this topic, the message of this topic, and a Knative service. So you get it a message to a topic, and then this message makes reacting your Knative structure and starting these pods. If you see now here, there is no pods because, as I said you before, you scale up, you scale up down automatically. And basically, that's all. There are some, as I said before, there are some resources like the end.dev Knative tutorial, so you can reproduce all these steps and more things. For example, how to use Kafka with Knative. Kubernetes tutorial is a tutorial. Quarkus tutorial is going to learn Quarkus. And that's all. I leave here again my information for just in case. But, we are almost out of time, so I'm going to stop sharing. And I don't know if there is any question. I know that I'm out of time. Sorry for that. But any questions, my email, my Twitter, and I will be very happy to answer. Thank you very much.
Thank you so much, Alex. It was great, a great talk, and very insightful and great demo. Yeah, thank you. I don't know why, but since we don't have questions, or at least I'm missing something on chat. Yeah, we just only have a comment, but not real questions. I don't know why, because the talk it seems the topic is very popular, and lots of very useful things you demonstrated. Sergey, do you have any questions from your side?
Yeah. I'm sorry, but I thought that the community would have questions. I mean, I was mostly working with AWS Lambda, and I see some similarities with Knative and what I have been working with, but I have nothing interesting.
Yeah. The big difference, I would say, there are a lot of more difference. Okay, but within Knative and AWS Lambda is that in one you are getting a vendor lock-in, and in the other one you can move to any cloud, and you're still having the serverless thing. And of course, I forget to say that with Quarkus we've got an integration with AWS Lambda, Azure Functions, so you can even get all these other things that I've shown you now, but specifically to Lambda or functions.
So can I use like those REST APIs, Jersey, yeah. Can I use Jersey to write AWS handlers with Quarkus?
No, you need to use, in this case, it's REST easy.
Oh, why so?
Well, because...
I mean, what's the difference?
Well, at the end, both are JAX-RS specifications, so you can, that they are compatible. The difference is that when you want to compile to native, you need to resolve all the things that happens just in time. So if you're in the JVM mode, you know that you are having just in time compilation. And when you're going to native compilation, you're having a hit of time compilation. So you need to resolve the things that usually are resolved at runtime, but at compilation time. Then this means that you need to do some tricky things, and we've done these tricky things for REST easy and not for Jersey.
Oh, I understand.
Yeah.
And do you?
Sorry.
Sorry.
Yeah, sorry. We received a question from Nishal. Or if you have something to continue, I think you can continue, and I'll get back to Nishal's question a bit later.
Yeah, I just wanted to ask if other cloud providers like Azure and Google Cloud Functions are supported. And it's the same, like I can use REST easy, write one code and deploy it everywhere if, for example, I need that.
Yeah, and even, as I said, we provide also the integration with the Amazon API. So you can still use specifically the Amazon API, and then we compile it to native, yeah.
You mean AWS client libraries?
Yeah.
And do you have any abstraction for example, data storage layer?
Not for data storage. We've got for these serverless APIs with a project that is called Funky. Okay, that it gives you an abstraction between Azure functions, GCP functions, and Knative events and AWS Lambdas. That's true, but not for data.
And I saw in Quarkus Starter that I can select MariaDB.
Yeah.
You selected. So JDBC driver can work with this technology, and I can use as last resort, for example, I can use MariaDB. Right?
Yeah. The support. I don't remember. I know the support is all the databases except Oracle DB, because it's there are some
probably have some native stuff.
The Oracle thing, the licensing and so on, yeah. But the rest of the DBs, I mean that Microsoft SQL, Maria, Postgre, I mean that MySQL, Maria, yeah, Postgre, DB2, all these databases are all well supported, yeah.
Yeah, good. Thank you.
You're welcome.
Cool. Then let's continue with the questions from the audience. The first question is from Nishal. Cold starts has slowed down the adoption of serverless and functions historically with the 5 millisecond startup time. Have we solved the startup problem?
Well, yes, yeah, I know. In fact, in case of the serverless, if you're going to for example, to using Go that you can compile to native, then you don't have this problem, right? Because it's a really quick boot up time. But if you feel comfortable with Java, this was the first problem, right? That you say, okay, I know Java, I don't want to learn Go, but I want to use serverless. Then with Quarkus, we solved this problem with 5 milliseconds startup time. Yeah.
Thanks. And another question from Nishal. I understand the DevOps monitoring environment is a little immature for serverless. Are there tools or best practices that are helpful that you could recommend?
Yeah, I agree. What we are seeing, it's not about the serverless, but we have seen in the event-driven architecture, where we, at least in our experience, where we have seen a lack of tools. In this case, we are just using Prometheus and Grafana, and yeah. So I don't have, this is the best tool, right? It's just we use Prometheus and Grafana, and it works. Okay.
Okay, thank you. And one more question from Aditya. When using Knative, is it still possible to have our own custom ingress controllers like with traditional Kubernetes?
I don't think so, but I cannot be 100% sure. That's the truth. I mean, I think that it's not possible, but if you find, somewhere in the internet or in documentation that says, yeah, you can change the ingress with this, I will not be surprised, okay? But as far as I know, I think that it's not possible.
Thank you.
I have one more question.
Yeah, go ahead.
You said that this kind of technology works with Prometheus, so you can get metrics. But Prometheus he's using scrapping, and if I'm running like serverless, the processes are ephemeral. So how could I scrap something when I don't have anything? Like, that's my question.
Yeah.
Do I need to use any kind of push gateway to correctly gather metrics, or is there any special plugin for it?
Yeah, I don't know if there is a special plugin. I know that as you've seen in the case of OpenShift, everything is integrated. So we've got all the logic out there. But if you want to use let's say in a vanilla Kubernetes, then I don't know if you should use some kind of proxy or not. Yeah, I don't know. Because I mean that in our case all the time we are using this OpenShift, which is Kubernetes plus some things, and one of these some things is that the Prometheus is integrated with everything. Yeah, but I don't know in a vanilla Kubernetes how this could be done.
Yeah, no problem. Yeah. I guess there is a solution for that. I guess we've done with all the questions.
Okay.
Thank you. Thank you for your talk.
And thank you very much for having me.
Yeah, and we have one more talk on first track. The interesting talk about the Northern Lights.
Mm-hmm.
So
that kind of talk.
Yeah. So we can, I think, end the session here, and I'll move there to the first track. Yeah, so see you there.
Okay, Bye. Thank you. Bye.
Yeah.
Thank you.
See you.
Bye.